Hello and welcome to Kognito Key. You know those massive power lines you see crisscrossing the countryside? Ever wonder how we manage all that incredible power and keep our electrical grid stable? Well, today we're diving into a remarkable piece of engineering that does just that, the Capacitive Voltage Transformer. Think of it as the hidden guardian of our power grid.
Just try to imagine the sheer force flowing through those transmission lines. We're talking hundreds of thousands of volts. Now, measuring this directly isn't just tricky, it's unbelievably dangerous. So the big question is, how do grid operators get a precise reading without, things going very, very wrong? Let's find out.
For a long time, the standard tool for stepping down voltage was something called a potential transformer. It works on a pretty simple principle of magnetic induction, kind of like your phone charger, but on a much bigger scale. But when you try to apply that same idea to grid-level power, you run into a huge problem.
That's right. Once you get above, say, 100 kilovolts, a normal magnetic transformer would have to be absolutely gigantic. We're talking unbelievably heavy, filled with vast quantities of insulating oil, and just crazy expensive. It's simply not a practical solution.
This is where the engineers had to get really creative. They needed a smarter, more elegant, and, frankly, more economical way to deal with these super high voltages. And their brilliant solution was the Capacitive Voltage Transformer, or CVT for short.
So what is this thing exactly? Well, a CVT is a special kind of transformer that uses a clever trick with capacitors to shrink that massive voltage all the way down to a much smaller, safer level, something that can be easily handled by our standard meters and all the protective gear on the grid.
And it pulls this off using three main parts that all work together in perfect harmony. You've got the capacitor stack, which does the first big voltage drop. Then there's an electromagnetic unit for some fine-tuning. And often there's even a unit that lets us send communication signals over the power lines themselves.
Okay, so let's pull back the curtain and see how this device actually works its magic. The whole idea is to take that wild, high voltage and gently tame it into something we can actually work with. The main principle here is something called capacitive voltage division. The CVT uses a stack of capacitors all connected in a series. The super high voltage is fed in at the top, and as it travels down through each capacitor in the stack, it gets divided into a much smaller and more manageable value by the time it reaches the bottom. So here's how that whole process plays out, step by step. First, that really high voltage, let's say 400,000 volts from the power line, enters the top of the CVT. Next, that capacitor divider does the heavy lifting, dropping it way down to a more reasonable 10,000 volts. Finally, a smaller electromagnetic unit does one last, precise step down to a standard level like 110 volts, which is perfectly safe for our meters to read. But you might be wondering, how do we make sure that final reading is perfectly accurate? Well, to cancel out any tiny errors or distortions in the signal, there's another clever component called a compensating reactor. It really acts like a fine-tuning knob, making absolutely sure the final voltage output is a true and precise reflection of what's happening on the main power line. So, now that we've got a handle on how a CVT works, let's put it head-to-head with the old technology, the conventional potential transformer, or PT. And as you'll see, the differences are pretty dramatic. Looking at this comparison, the choice becomes crystal clear. While a traditional PT is fine for lower voltages, the CVT is the undisputed champion in high voltage situations. It's way more economical, it's significantly lighter and more compact, and it offers a level of versatility that the old guard just can't touch. So the key takeaway, the magic number to remember is this: anything above 100 kilovolts. That's the point where the cost savings and practical benefits of the CVT make it the absolute no-brainer choice for high-voltage power systems. So where do we actually see these incredible devices in action? Well, if you've ever driven past a large electrical substation, you have definitely seen them. Those tall, slender insulators are rows and rows of CVTs, all standing there quietly doing their critical work. Their job is really threefold. About 40% of their function is for metering, just getting an accurate voltage measurement for things like billing. Another 35% is for something called protective relaying. This is where they detect faults on the grid and tell circuit breakers to open, which protects all the expensive equipment. And the last 25% is for something really amazing: power line communication. And this is where it gets really, really cool. CVTs can actually inject high-frequency communication signals right onto the main power lines. This lets grid operators send data for remote control, system monitoring, and even voice communication all over the existing grid. So it's a measuring device, a safety device, and a communication hub all rolled into one.
And that's really why this technology is so valued. It takes a simple principle from physics and applies it to solve this huge, complex, and dangerous problem. And it does it in a way that's not just effective, but also cost-efficient and unbelievably versatile. It's just brilliant.
It really makes you wonder, doesn't it? The CVT is one of these hidden giants, working silently behind the scenes to keep our lights on. What other critical pieces of technology are out there, completely invisible to most of us, but are absolutely essential to the way we live our modern lives? And that's our look into the capacitive voltage transformer. If you enjoyed this and maybe learned something new, please do give this video a like, share it with someone who's curious, and of course, subscribe to Kognito Key for more deep dives into the amazing tech that powers our world. Thank you so much for watching.